Bow! Hey, hello and welcome to the show. It's me, John Park, and this is JP's Product Pick of the Week. We are here together on a Tuesday. Thanks for stopping by. Thank you, everyone, over in our different chats. If you're somewhere where it's mysteriously silent in the chat, check out our Discord. It's at adafruit.it/Discord. Look for the live broadcast chat channel. It looks like this right here. That's the live broadcast channel. We got a bunch of other channels in there, but that's the one where people hang out during the show. Hello, Paul Cutler, squid.jpg, ADCC, Bob, Johnny Bergdahl, hello. We do also have the chat active over on our YouTube. So hello to Dave Odessa, Beata Graf Hagen, KC, and Johnny Bergdahl also showing up over there. Thanks for coming by. Thanks for hanging out. Thanks for chatting. What's this all about? What happens here? This is the Product Pick Show. I've got a product pick from our archives, one that I love, one that I still use a lot. It's not a brand new one, but it's an excellent one, I think. And what I do is I send you to the product page. If you would like to, head right there. That will take you to the product page, so will that QR code. This show is being broadcast from inside the page, so you can watch the little YouTube right there. And you will see that our product pick has been discounted. It's 50% off, so go there. You don't need a coupon code. All you got to do is throw some in your cart if you want to get them along with some other stuff. But this product will be half off during the show. The price will go back up afterwards. But if you want to go and take advantage of this, I encourage you to go there. Go check it out. That'll let you know what it is. You know what also will let you know what it is? Not a what, but a who. It's Lady Ada. Take it away, Lady Ada.
The ItsyBitsy M4. It's here. It's got that SAMD51. It's running at 120 megahertz. It's got 512K of flash. It has 192K of RAM. It's got a ton of pins. It's got 2 analog outputs. It's got like 7 analog inputs. Both of those are 1 megasample per second. So you can do 1 megasample per second input and output for analog, which is pretty cool. The only thing this doesn't have is I2S. Why? I don't know. Ask Microchip. For some reason, on the 48-pin version of this chip, they took out I2S. It makes no sense to me whatsoever.
Want to show it there, or do you want to just keep going?
Let me just show it. You know, these photos are like, because it's so small.
Okay.
So it's breadboard friendly. It's got pins all the way around. It runs CircuitPython, or you can use our Arduino core. Either will work just fine. But the great thing is it's just so fast. 120 megahertz. This is just blindingly fast. You know, we have the cache on. It has a floating point unit. So if you're doing stuff with floating point, where on almost every other Arduino compatible chip you'd have to do that in software, it has single precision floating point support built in. It has DSP built in. So we ported the PJRC Teensy audio library to this to test out the DSP. And yeah, it can decode MP3s on the fly. It can do audio synthesis. Really cool, powerful chip with that dual DAC and multiple analog inputs. We have a small SPI flash chip on there with 2 megabytes of SPI flash hooked up in QSPI mode. So we have a QSPI library in Arduino, and in CircuitPython we use QSPI natively. It's so much faster than SPI. So you get, if you're running CircuitPython, you get that really good feeling of fast Python action. Like you're not feeling like it's sluggish or you're running out of memory. In fact, I have not been able to run out of memory while running the M4 series yet. You pretty much could write as much code as you want. And with 192K of RAM, which isn't a lot for a computer, but for CircuitPython, it's a ton.
It's huge.
Yeah, you can do a lot. Big buffers. You know, you're like, just buffer all the data. Why not? You can. You have 192K. So that's the ItsyBitsy and a lovely chip. And then maybe the Feather M4 coming soon.
Okay.
Yeah, that's right. That's it right there. In fact, it's so small, you didn't notice that I had one right here in my glasses the whole time. Maybe not the whole time. I think I lied. That's it right there. My product pick of the week this week, it's the ItsyBitsy M4. This is an SAMD51 chip. It has 192K of RAM. It's got 512K of flash. It has 2 megs of SPI flash for storage. There's a ton of GPIO. You can see this is the wrap all the way around the board with the GPIO pin structure. In fact, let me bring up this set of images here so you can see it a little better. It has 23 GPIO pins, 7 of them are analog to digital converters. It has 2 digital to analog, so you can do stereo audio output. It comes with CircuitPython loaded on board, which isn't true of all our boards. So that means you can get this in the mail, plug it in, immediately start coding right inside of a text editor. And you can use Arduino on it, but this starts out with CircuitPython on it, which is a real nice bonus, I think. It has really great performance for synthesizers. So if you need to build a synth with a tiny little board, this is an excellent choice for that. You can do synth.io in CircuitPython on it. As Lady Ada mentioned, we also ported the Teensy audio library to M4, and it runs on this. And you get stereo out, which is pretty terrific. There are a lot of great projects out there that people have done with it. I'll take a look at some of the ones that are up on Adafruit Learn in a moment. But let's see. Let's get started with some pages here. This right here is the product pick. It's item 3800. So you can go to adafruit.it/3800. That'll take you right to the product ID page. It is $7.48 just during the show here. I think we had 100 of them stashed in stock at a minimum, so you should be okay if you want to get one before the end of the show or grab a few. You get 10 of them maximum per customer. There are a couple of neat things that you can get as add-ons. So you can see it's a tiny little flat board. You may want to keep it that way and solder to it directly. You could use some little short header pins. We have these nice little shorter than usual header pins and header sockets right here if you want to get a set of those and put them on a perma-proto board. That's kind of a nice way to move from breadboard over to proto board. You can see it here on a breadboard. I mentioned breadboard, so I will say there are a couple of really neat projects that C. Grover from our community, Cedar Grove Studios on GitHub, has made. You can have these ordered at places like Osh Park or PCBWay. They are a ItsyBitsy breadboard adapter, which breaks out the edge pins to continued pins there along the same parallel long sides so that you can put that on a traditional breadboard without losing the use of those extra pins there. It also has a battery charge circuit on it and a JST connector for our typical batteries. I think it has does it have the charge circuit? It might be only this one does. There's another one here that's the charger backpack for M4. So there's a few cool projects there, little add-ons that Cedar Grove has put together. We also make this little guy right here, which is a battery backup, a battery backpack. So if you are determined to go with ItsyBitsy, you don't want to go over to the Feather for whatever reasons, but you do want to do some, you want to have the option at least to do some battery power. This is an option right here. This is the Learn Guide. So if you scroll down in our product page a little bit, you'll take a look at the Learn Guide here. Here's a nice big photo of it. We've got the Pinouts right here, so you can see we've got, I think, 13 of them that can do PWM, 18 of them that can do PWM. That makes more sense. I mentioned we have all these analog inputs. We have the 2 DAC outputs, so you can get all that info here, as well as all the Circom, UART that you can shake a stick at, I2C, SPI. All those things are broken out on the board. It's got just a ton of I/O, which is great. If you take a look at some info about the power pins, this is an interesting one because it does give you a 5-volt high pin as well as one logic pin. Pin 5 is on 5-volt logic, and that's really important for backward compatibility with older projects. There are some projects that really don't want to run with the more typical modern 3.3-volt logic pins. So if you've got a project where you think that's going to be an issue, take a look at the ItsyBitsy. It could solve your problems there. We do have a .star RGB LED on board for indicator and other use. There's also a traditional pin 13, Arduino tradition, pin 13 LED that you can blink to make sure things are working. And on and on and on. So we've got lots of info here on the pinout page that you can check out. Some info about setting it up and using some samples, sample code for Arduino, as well as CircuitPython. And you can also go to the downloads section to take a look at the ATSMD51 data sheet, as well as we have a fritzing object for it if you want to pull it into fritzing, and CAD drawings, 3D models, all that good stuff is here. Let's see, I think someone was asking over in our chat, just bring up the chat for a second here, they answered their own question, where is the JP1 on the board? And there's a little pinout diagram there showing what is what's down along the bottom edge row there. Let's see, what else did I want to talk about or show you? Let's take a look at a pretty cool project demo here. So Lamore suggested that I put one of our round displays on here. So you can see, let me go full screen for a moment and we'll take a look at the code. Let's see, pull that off of there. How's that focus? That looks pretty good. Let me touch that up just a hair on the big screen. Oh no. Yeah, there we go. So you can see right here, I've got one of our round displays. This is a GC9A01A driver. And I've got the ItsyBitsy right here on a breadboard. I have connected it up to all of the broken out pins for the display there. And this is a sketch that Todd Kurt put together. It's up on his GitHub. You can see it uses a dial indicator graphic as well as a separate element for the needle and a potentiometer to adjust the positioning of that. And one of the beautiful things about this running on the ItsyBitsy M4, I'm going to block a shadow right there, or a glare, is how fast it runs. Look how quick that display update is. We've got no flickering. This is a nice display here that I can see from all angles as well. ItsyBitsy keeps up with this. The ItsyBitsy is fast. It's really capable for driving displays, really capable for SynthIO stuff. So if we take a look over here, this is all running in CircuitPython. Here you can see is the code. The main things we're doing here are display I/O stuff, as well as this driver here. There are community drivers for this. The GC9A01 is the driver for this board. We also have an Adafruit specific one here that I think just has some specific configuration changes. We've got some graphics that we're pulling in that are just on disk on the ItsyBitsy itself. And then we're setting up all of the SPI display pins right here, as well as an analog input for that potentiometer using display bus. And then the main loop here is just taking a remap of the values, the analog values that we're reading in on one of those 7 analog in pins. So we could build a whole dial gauge display here if we wanted to, a dashboard with a bunch of dials if you had a project like that. And this would handle it. And so we've got, you can see here, the display is just using RotoZoom to adjust the position of this little dial indicator here. And I've got some text on there that reads ItsyBitsy M4 Express. And the Express in the name, that indicates that you can boot this up as a CircuitPython drive, as a USB drive, and just drag your files onto there. You can drag UF2 files onto there if you want to update that. If you want to put an Arduino file that's been baked for that board on there, you can do that. So it's a good board for distributing projects. In fact, I believe this is one that's being used for some Eurorack synth projects out there. I built one. I'll show you this. This is the Fader Wave. I'll show you the project. This is a wavetable synthesizer, so we can construct the shape of the wave there that'll internally look something like that, using all of these sliders, and then send it MIDI, and it'll output the audio using the SynthIO audio output. If we take a look back at our Learn guides, let's find it. There's the Fader Wave project, so that was using an ItsyBitsy M4. You can also do that project with the ItsyBitsy RP2040. Do we have one like that? Is that a real thing? There was another Itsy, I think, that I had that running on. I can't remember which one it was, but this one right here that I have, this is running on the ItsyBitsy M4. Good project for that, really good project for SynthIO stuff. We've also got, here's one I did a while ago using an ItsyBitsy to do a key bow, which was a Pimeroni little macro pad project using dot stars. Here's a nice one in CircuitPython using an OLED and a couple of potentiometers to do an Etch-a-Sketch that Carter Nelson put together. here is, it drives displays great, so here's an animated sprite pendant that the Ruiz brothers put together with a nice flying toasters there. And I showed you some of those add-ons that C. Grover had put together. So very capable board, really extensible. It does have I2C. DK asks over in the chat. There is, I believe on one of C. Grover's boards, there's a breakout for Stemma QT. I could be making that up. There might be a way to break that out for Stemma QT, but yeah, there's definitely I2C. If we take a look back at the pinout here, this is a good place to find answers to that. You can zoom this in and find answers to a lot of those questions. We usually have a color coding for some of the outputs, and we'll also mention it in the individual sections. There is up at the top row here, there's a I2C pin SCL and I2C pin SDA. That's what you use for I2C. I'm not sure if there's a second. I think there's maybe just the one I2C. And then lots and lots of GPIO that you can see there. Here's this special pin 5 that's tilted sideways and has some marks on the silk screen there to let you know, hey, this is a 5-volt pin, so use this one for your 5-volt logic needs. And we have this V high down here at the bottom in the power section. If you look at these power pins, V high, that's a 5-volt pin, and then this is the usual 3-volt pin, USB, which is often going to give you 5-volt, and battery. But since we have the voltage conversion going from the incoming to a pure 5-volt that we can use for the 5-volt pin 5, logic level 5-volt, then you can access that on the V-high pin as well. Let's see. I think that covers all the things I wanted to cover. Let me know if you have other questions. And I'll show this lovely demo here off again. This is, I built a little 3D case for it, but you can see, oh, this is just a ribbon cable to make my life easy, and then running to the many requisite pins for SPI display driving that are built into the ItsyBitsy right there. Has a reset button built on. USB is a micro USB-B. Keeps it compatible with all of the ItsyBitsy. I don't know if we'll ever do an ItsyBitsy with USB-C on it, but that one does have the micro B, so be aware of that. All right, I think that covers it, yeah? So let's, let me just remind you, this is the page right here. If you want to go pick one up, go pick up a few. They are half price until the show is over, then they'll go back up. And that is at product ID 3800, $7.48. What a bargain. Great, robust microcontroller board for you. All right. Well, thanks everyone so much for stopping by. That right there is the product pick of the week this week. It is the ItsyBitsy M4. For Adafruit Industries, I'm John Park, and this has been JP's product pick of the week. I will see you next time. Bye-bye.